Yes, I'm going to be giving quite a kind of practical talk, about trying to do sentiment analysis on all kinds of different types of text. So, like most language engineering tasks, sentiment analysis works best when you've got a very specific domain, you're working on a single language, where the task is very clear-cut, and the range of options is kind of limited. So this means that tailor-made approaches to sentiment analysis are the key to success. Off-the-shelf tools are therefore not likely to work so well when they're used for different tasks, and there's a whole range of research in trying to adapt these tools to different tasks. So this is great when you want to find opinions about the latest films from a single film review site, written in English, so you can train models for this purpose and you can get reasonable results. All very well and good. But what happens if you want to do more complex kinds of analysis on a potentially unknown set of documents containing potentially unknown kinds of entities? So there's a kind of language processing trade-off, and this applies to all kinds of language processing, not just opinion mining. So as you go from, on the one hand, from a very simple task, so for example, bag of words, as you move to a more complex task, so for example, entity recognition is harder, relation extraction is harder than entity recognition, event detection is even harder, and opinion mining is probably off the, even further off the scale, because that's really a hard task to do well for NLP. So as you go along the scale and get more complex, the accuracy tends to go down. On the other hand, as you go from a very domain-specific approach, so when you're working on, for example, a set of quite homogeneous news texts, as you move to a more generic kinds of text, then again the task gets harder and you get worse results. So when you combine the two things, then you really are in trouble. So the task we're trying to solve here, we're working on two very different domains. This is a part of work we're doing on a project called Archimem, which is an EU-funded project. And our use cases are, on the one hand, Greek and Austrian parliaments. So we're trying to find sentiments in texts from the Greek and Austrian parliaments. So things like how people's responses to parliamentary bills and so on. On the other hand, German rock concerts. So quite a diverse range of stuff. That's because the rock concerts are sponsored by one of our partners in the project, a German media company. So ultimately, we want to find out what are the opinions on crucial social events and who are the key people involved? How are these opinions distributed in relation to demographic user data? How have these opinions evolved? Who are the opinion leaders? What's their impact and influence? So the first task is to try and investigate public opinion about key entities and events. And that's what we're going to focus on here. So we know sentiment analysis is hard to do well. And it's even harder in our case because we've got lots of different text types and domains. We're processing social media, we're processing multiple languages, and we don't necessarily know what we're looking for. So we've been experimenting with different techniques and different subcomponents to try and build up a kind of complex system, and experimenting with techniques for cross-language adaptation. So we're using GATE, which is a tool for language engineering. And the main reasons for this, apart from the fact that we are the GATE developers, is because it's robust and it's adaptable with a kind of component-based architecture. So we've got lots of experience adapting information extraction applications to different languages and domains, something I in particular have been working with for the last 12 or so years. So the question is whether we can do the same kind of thing for sentiment analysis. And the main challenges of this are how can we easily port sentiment analysis to a new language, and how can we process documents in multiple languages most efficiently? Secondly, how can we easily adapt applications which work on standard reviews to deal with noisy kinds of social media. So we use a rule-based approach, and the reason for this is mainly because although typically machine learning applications are used in opinion mining, the task at hand involves documents, as I said, from many different text types, genres, languages, and domains. And this is problematic for machine learning because it requires lots of applications trained on all the different data sets or methods to deal with acquisition of training material. So we aim to use a rule-based system. So the bulk of it can be used across different kinds of text with only the pre-processing and some sentiment dictionaries and so on, which are domain and language specific. So we can break this down into the following set of components. We have some structural pre-processing, which is specific to the social media types. So, for example, extracting the content of a tweet from the metadata and so on. Linguistic pre-processing, so this is things like language detection and other things like tokenization, sentence splitting, and so on. Then we have some kind of standard language-specific named entity, term, and event recognition modules. Then we have additional targeted language and task-specific gazetteer lookup. We have JAPE grammars. JAPE is a pattern action language that we use in GATE for for creating rules for, in this case, opinion finding. And finally, some aggregation and summarization techniques. So in GATE, you can set a processing resource in your application to run or not, depending on certain circumstances. So you can have several processing resources loaded, and then you let the system automatically choose which one to run for each document. So this is very useful when you've got text in multiple languages, or text of different types, which might require different kinds of processing. So, for example, if you've got a mixture of German and English documents in your corpus, you might have some processing resources which are language dependent and some which aren't. And you can set up the application to run the relevant resources on the right documents automatically. So imagine we've got a corpus of documents in German and English, and we only want to process the English texts. So first we have to distinguish between the two kinds of texts. And for this we use a language identification tool. We use TextCat, which is implemented as a plugin in GATE. It's a standard tool that's freely available. And we use this to add a feature onto each document, which tells us which language the document is in. Then we run a conditional processing pipeline that only runs the subsequent resources if the value of the language feature on the document is English, and the other documents will simply not be processed. What happens if we want to process both English and German? Well, in this case, we just call some language-specific processing resources conditionally, and we use the language-neutral processing resources on all the documents. What happens if the documents themselves are in multiple languages? So we get this a lot. We see this in particular on the Rock am Ring, the German Rock Festival data, where we're processing lots of blogs, and people actually write in multiple languages, even within the same post. So they'll write one sentence in English and then a sentence in German, and so on. So in this case, we have another processing resource called segment processing PR. And this enables you to process labeled sections of a document independently, one at a time. And it then merges back the individual sections once they've been processed. So basically, you identify different sections, it separates them out, you can run different resources on each section, and then it merges everything back together. So this is useful when you want annotations in different sections to be independent of each other. When you only want to process certain sections within a document, and when you want to process multiple languages separately. So here's an example of a document from the Rock am Ring blog where, as I say, we've got English and German together. For some reason, one of the biggest topics of conversation in these forums is the state of the toilets and showers at the rock festivals. Seems to be the thing people are most concerned with. So as you can see, we've got the purple text is the English, and the blue text is it blue? Blue or green? I don't know. Sorry, I'm kind of colourblind. The colour that's not pink is the German. And you can see on the labels on the right-hand side show that, say, English content and German content. And here's just an example of some sentiment finding. So here we've got various sentiment words which have been annotated in, I don't know what colour, you can tell what colour it is. And various processes go on underneath, which I'm not going to explain in great detail because I haven't got time. But essentially, lots of information is combined to produce a final sentiment feature on the entity, which in this case is In Flames, which is the name of the band. And we have some features associated with that. So we have a positive polarity, we have a score, and so on. So how do we create these language-specific resources? For linguistic processing, pre-processing, we have a standard set of tools to do part-of-speech tagging, language ID, and so on for the different languages. We do, as I say, we use named entity and term recognition, again, using some language-specific plugins that we've defined for the different languages. We then have the problem of creating new gazetteer lists for our different languages. So we do this in a number of different ways. We do some automatic translation of gazetteer lists from English. So this might be sort of standard things like, I don't know, names of bands, names of people, days of the week, months of the year, whatever. We collect some lists from the web. So, for example, we collect things like lists of swear words, lists of typical phrases. So, for example, I've got a whole list of phrases for things that go bad, like going down the drain, going to the dogs, and so on. So we can collect lists like this. You can find all kinds of things on the web these days. Lists of swear words, lists of odd phrases, and so on. So that's been great fun collecting these kind of things in different languages. We also have some process for automatic gazetteer induction from texts. Which is a kind of bootstrapping approach where we annotate some text, we automatically produce gazetteer lists from certain annotations, and then we look at the context surrounding these. So, for example, verbs of the same type that precede a particular kind of word, and then we collect new words to add to the gazetteer list, and so on. So that's basically what we do for the gazetteers. Everything else pretty much is language independent. So we can use, to say, the core stuff, which is language independent. So most of the rules for actually doing interesting things with the sentiment, attaching things like adverbs, calculating scores, and so on, are all language independent. And it's only these very specific kind of lists and things which we have to adapt to the different languages. Same kind of thing applies for domain-specific resources. In this case, however, documents only ever tend to be of a single type, so we don't have this problem of different kinds of text types, obviously, within a single document that we have for the languages. However, social media poses challenges for linguistic processing. So, for example, we need specially developed resources with more flexible kinds of matching, special handling of tweets, and so on. So we need different versions of things like tokenization, part-of-speech tagging. Just an example of a tweet, it's not written in very good English. You know all about this kind of stuff. So I think Twitter in particular is probably the source of the most degraded kinds of information. So if you compare this to something like parliamentary texts, which are written in very good English or German or whatever, there's a big contrast. And so that's why we need these sort of different tools for even the pre-processing stage. And it's really crucial to get this right, because if you don't tokenize your stuff right, if you don't have the right parts of speech attached to it, you're never going to be able to do all the rest of it. So that's really crucial. And we've been doing a lot of work on that in another project called TrendMiner. There's some references at the end of this, these slides to all this work. Things like sarcasm as well tend to occur a lot more frequently on less formal texts. That's actually not so much an issue because if we have some kind of sarcasm detector, we don't need to run it on the more formal texts. So again, we can use conditional processing on a document-by-document basis to deal with these kinds of issues. So to sum up then, it's best if you can tailor your application as much as possible to the domain and language. However, if you do have to process multiple kinds of text, a modular rule-based approach can allow you to combine the specific resources with the generic resources. Gate is ideally set up for this, but obviously there are lots of other tools which are available too. We use a rule-based approach, but there's also lots of current research on automatic induction of new training data on different kinds of text. So, as I say, machine learning approaches are possible, but we've decided to go for this rule-based approach. More information about Gate, more information about the ArcMem and TrendMiner projects, more information about dealing with the problems of social media, and so on. And that's it. Any questions?
Hi. Obviously, when you have different classifier, for example, for different languages, there must be a problem. They would have different precision and recall. When you're comparing, when you're analyzing documents, say in German and in English, how do you put it on the same pedestal, if you will, when you're comparing comparing sentiment?
Sorry, I heard all of that except the very last bit.
We're comparing sentiment between two documents,
Yep.
One in German and one in English, because you have two different classifiers. They have different different precision and recall. How do you see? Have you faced similar challenges like that, and how do you deal with it?
So I'm not entirely sure what the issue is that you're concerned about. How do we?
So you're building a one-size-fit-all. You have a number of classifiers essentially for different languages, right?
Yeah.
They would have different effectiveness, how good they are.
Yeah.
Yeah. How do you come into a situation where you have to compare results for different classifier because you need to present one report, for example, for a mixed language corpus?
I see what you mean. So currently we haven't actually done any evaluation on the documents where we get mixed, for example, German and English within the documents. But essentially what we do is, for evaluation purposes, we manually annotate the documents. So at that point, it doesn't actually matter whether which bits are in English and which bits are in German, because we just have one single set of annotations, and then we just automatically compare them. So we get an overall evaluation score for the English and German combined. The English does tend to evaluate better than the German, just because that's the language that we've worked the most with, and so we're, as I say, we've been looking at adapting this to the different languages. So the English stuff will always get a better score at the moment, anyway. But something that we're looking at, and we haven't done much evaluation on the German yet, is this issue of kind of how easily it is adaptable and what kind of problems we get with this. So yes, in summary, we evaluate it as a single entity rather than evaluating the German and English separately. But that's something we need to look into as well.
Thank you, Dan.
Okay.